This lesson is for integration by parts. Every differentiation rule has a corresponding integration rule. For instance, the substitution rule for integration corresponds to the chain rule for differentiation. The rule that corresponds to the product rule for differentiation is called the rule for integration by parts. It is derived from the product rule, which states that if f and g are differentiable functions, then the derivative of f of x times g of x equals f of x times g prime of x plus g of x times f prime of x. Then you take the integral of each part to get the equation. The integral of the derivative of f of x times g of x dx equals the integral of f of x times g prime of x dx plus the integral of g of x times f prime of x dx, which then simplifies to f of x times g of x equals the integral of f of x times g prime of x dx plus the integral of g of x times f prime of x dx. We then subtract to get the integral of f of x times g prime of x dx, which equals f of x times g of x minus the integral g of x times f prime of x dx, which is your formula for integration by parts. To put the formula for integration by parts into a simpler form, you can let f of x equal u, which means f prime of x equals du, and also let g of x equal v, which means g prime of x equals dv. This gives you the formula: the integral of u dv equals uv minus the integral of v du. This is the exact same formula as we derived earlier, which was the integral of f of x g prime of x dx equals f of x times g of x minus the integral of g of x f prime of x dx.
Now, you're probably wondering, why would I ever use integration by parts? Am I right? Well, you may have come across a problem before that cannot be solved with basic U substitutions or just simple reverse chain rule. For these situations, we use, yes, you guessed it,
oh my gosh, baby, let me.
Here's the formula for integration by parts, which we derived earlier. We're going to use it to solve the following example, to find the integral of x sine x dx. I'm going to write the problem again. And for this example, we'll let f of x equal x, which would mean f prime of x equals 1. G prime of x will equal sine x, which means g of x equals negative cosine x, which is just a general antiderivative. Now substitute these back into the equation to get negative x cosine x minus the integral of negative cosine x times 1 dx. To simplify this further, you get negative x cosine x, and then pull out the negative to get cosine x, integral of cosine x dx. Now we solve the integral and get negative x cosine x plus sine x plus c.
This next problem is a little bit more difficult because we're going to be using integration by parts twice. So in this example, we're finding the integral of t squared times e to the t dt. And in this problem, we're going to let f of x equal t squared, f prime of x equals 2t, g prime of x equals e to the t, and g of x also equals e to the t. So now we find by using the formula for integration by parts that the integral of t squared e to the t dt equals t squared times e to the t minus the integral of e to the t times 2t dt. And we're going to simplify this by taking the 2 out of the integral. And we now take this next integral, and we can't solve this using reverse chain rule or use substitution, so we're going to use integration by parts on this integral as well. So now we're trying to find the integral of e to the t times t dt. So we're going to let f of x equal t, f prime of x equal 1, g prime of x equal e to the t, and g of x is also going to equal e to the t. So using our integration by parts formula, we can now say that the integral of e to the t times t dt equals t times e to the t minus the integral of e to the t dt. And we simplify this to equal t times e to the t minus e to the t plus c. So we now take this answer and we plug it back into our original integration by parts problem. So now we say that t squared times e to the t minus 2, in parentheses, t times e to the t minus e to the t plus c. And we simplify this to equal t squared e to the t minus 2t e to the t plus 2 e to the t plus c.
Now here's the solution to the problem, so check your work and make sure the two match up.
Get a good feeling, yeah.